Okay. All right, so we're gonna look at a more complicated problem now. One of those awful story problems. Okay. H sold X cell phones in 2013. The number of cell phones he sold in 2014 was 128% greater than in 2013. And the number of cell phones he sold in 2015 was 29% greater than in 2014. Which of the following represents the number of cell phones H sold in 2015? So they're basically asking you to convert these numbers into percentages.
So
I'm sorry, the percentages into yeah. To decimal, yes. Okay. You said B?
Yeah.
So the problem with B is that the 0.29 would actually decrease, would cause it to decrease.
Yeah.
And that's how we know it's not, because it had to go up. Because if it was 100 and 29% of 100, well, it went down. So that's why it's got to be this last one here. So you take the percentage 1 plus the 0.29, 1 plus the 1.28, and that's how you come up with that. You did it correctly last week. I know it's a little awkward, but and it depends whether you're dealing with decimals or percents. Let me see if I can find another one like that. I guess they don't have any more of those in here, but yeah. So if the number is you're always adding 1 to the percent when it's increasing. I guess that's the best we can do there. Okay, so let's look at this one's kind of related here. I'll have you read this one out loud for us.
The number of books in a library increased by 30% from 2002 to 2014. There were X books in a library in 2002. Which expression represents the number of books in the library in 2014 in terms of X?
Okay, so it's kind of like the last problem. Are you going to use 30% or do you need to add 1 to it?
You're going to need to add 1. Or
Yes.
you're going to...
So that's the way I mean, sometimes you just pick a number. Like, let's say there was 100 books, okay? And if it increased by 30%, if you multiply by 0.3, yeah, that gives you the increase, but it doesn't give you the total number of books. And that's what you want. You want the total number of books. So that's why you got to take 1 and add it to the 0.3.
Okay.
Okay, so that still doesn't give us our answer here. Which one is the correct answer?
It should be A, right?
So A is 130. What is 1 plus 0.3?
Oh, 1.3.
Yes, 1.3. Yeah. Okay. We're gonna these are like low-hanging fruit problems. We want you to really get these because they're the easier ones. Let me go back and see if I can find some more here. So let me. Okay, here's another one. For us to try. Okay, the budget for a school band was $8,000 in 2010. The budget decreased by 15%, okay, from 2010 to 2011, and then increased by 22% from 2011 to 2012. So that increase, what is that increase in 22%? What is that as a decimal?
1.22.
1.22. So in the same way that you add when it's an increase, you subtract when it's a decrease.
Be 5.
0.85. So which of these has 0.85, 1.22, and the 8,000 in it?
B.
Letter B. So what are you going to do to remember that? Because it's kind of confusing. I mean, it's fine now that we've done it, but what are you going to do to remember that on the exam?
Um, I gotta remember that decrease, I gotta subtract, and increase, I gotta add.
Add one, right? And
Yep.
subtract from one. Okay. All right. All right. So here we go. Here's another question. Go ahead and work that out on your own, please.
It should be C, right?
Which one?
C.
C. Yes. Got another one here like this. Okay, go ahead and read this one. See if you can work it out on your own, please.
It should be D.
I agree. Yeah. Okay, a couple more here. One of these is like a going backwards type problem. So let's look at this together. Okay, it says the height of a certain tree in 2016 was 1.35 times the height of trees in 2011. By what percentage did the tree increase? So really what you're trying to do is go from the percentages to this number here.
Should be C, right?
It is C, yeah. And see, it's kind of confusing, but you got it there. Okay, let's look at the next problem here together. Okay, so customers' monthly water bill was $75.74. Due to a rate increase, her monthly bill is now $79.86. To the nearest tenth of a percent, by what percent did the amount of the customer's water bill increase? So there's a formula for percentage increase and decrease. And I like it this way. It's the new minus the old over the old. Have you seen that before?
No.
Okay. What is the new price in this problem?
Yeah, it should be $79.86.
Okay. What is the old price?
$75.74.
Okay. Now you got to be really careful how you put this into your calculator because your calculator is dumb. It only does what you tell it to do. So if you don't put the parentheses in the numerator, your calculator doesn't know that you meant to put those in there. So are you comfortable entering this into the calculator for me?
Sure.
Okay, go ahead and do that and let me know what you come up with.
$75. I got 0.054396662.
So 0.054.
Yeah.
Okay. That's a decimal. How do you convert a decimal to a percent?
Move the decimal over 2 times.
Which way, right or left?
Right.
Right.
Sorry.
So what would that be as a percent?
5.4%.
5.4%. Good. Okay. I think the next section.
Oh.
So we actually don't know why we yawn. Like we all think it's because it's a lack of oxygen, but I think I read a paper that said it's not necessarily that.
Really?
Yeah. I still think it's because we're tired.
That's what I think it is because I don't do it.
Or when you're doing math. Math, not meth.
Also,
Okay. Let's go here. Sorry, I'm looking for another problem like this one. I don't know why I'm not able to find one. Okay, so I want you, I'm going to give you a data set here. I want you to find the percentage increase from 2012 to 2013 of subscriptions.
okay.
I'm going to keep looking for some problems while you're working on that.
I got a 5%.
5.0%.
Yeah.
Okay. Okay, so here is a new problem for us to look at. So there's also, and this is what I was looking for a percentage decrease problem. A car was listed with a price of $12,000. The price decreased by P% to $9,600. What is the value of P? So I mentioned this before, the formula is new minus old
Overall.
over old. Which is the new and which is the old?
What's the price? 12,000. It should be 12,000.
So the new price is the one it's going to. That like it's a directional thing. So
Oh,
this,
okay.
so this is new. And if you don't like those words, we can change it. But I like these words versus what they have in textbooks. What were you going to say? I'm sorry, I interrupted you.
No, you're good. I was just like just putting it together what you were asking. Sorry.
Yeah, it's like you play a basketball game, and last game you scored 12 points. That's terrible, and then you only scored nine points. The new is the latest one. Latest maybe is another word you could use. But go ahead and calculate this for me, please, and let me know what you come up with.
I got -2%.
Is that to one decimal place, or is that just rounded?
Or I guess 20%. Sorry.
Okay, I'm gonna calculate this one because I want to make sure we got it. Okay, yeah, so it's minus 0.2. Okay, now the word decrease, that takes care of the minus.
So you can get rid of that.
Yeah, so P is the percent. So what is 0.2 as a percent?
20%.
20%, good. Okay, so if it goes down, this new minus old over old is negative. Okay, so question for you. How many points per game did you score last season? Do you remember?
21.
21 points per game. What would you like to score this season?
26 or higher.
Okay, so let's go 26. So I want to know the percentage increase to go from 21 to 26. You got to figure out which is the new and which is the old. And the arrow tells you the direction you're going.
26 or 26 is the
That's right.
it's a 23% increase.
Yeah, I would round that up to, so we want to write the decimal. Let's write it out a little bit. So let's go 0.238.
8.
So this would be 23.8% increase. Okay. Do you know how many shots per game you were taking to score 21 points?
16.
16. Okay. So if you were to, what do you multiply 16 by to figure out how many new shots per game you're going to have to take?
That percent, 23.
So if you multiply 16 by 23, though, it's going to get smaller. So what do you need to do to 23?
123.
Yes, you have to multiply by one, not 123, 1.238.
0.238 times 16.
No, you want to multiply by 1.238.
Yep. It's 19.808. So
So about 20 shots per game. But is that, I mean, you play basketball, and then we're going off to the side here, but a little bit. Is that really the right way for you to score more points, is to just to take more shots?
Not really, no.
Not always, right? What other things could you do?
Get fouled more.
Be more efficient, get fouled more, things like that. Okay. Okay, let's look at one more question here. This will be our last percent question, and then we'll move on to a new topic. The table gives the typical adult weight ranges and lifespans for African and Asian elephants in the wild. Based on the table, the typical lifespan of the African elephant. So which column is the African elephant?
The left.
This one right here. So that's what we want. Is P% greater than the typical lifespan of the Asian elephants? That's the one on the right. What is the value of P? Now, which row do we want? We want the one for lifespan. Which of these three is lifespan?
The bottom one.
So we're really looking at those two numbers. Okay, and we're going to which direction are we going? Are we going from 60 to 70 or 70 to 60?
60 to 70.
Yes, because that's for the greater.
Okay.
Okay, so greater tells you the direction you're going. So you tell me, you figured that out. You give me that percentage, please.
Okay. So we said 60 is the new number.
You're trying to go greater, so that's why it's sometimes good to draw kind of a direction.
Okay. So I got negative 16%.
But it's
Or
greater. It can't be negative.
okay, then I did it again and I put 70 minus 60 and I got 0.1428.
Okay, so this is one of those, like you mentioned before, you've got a thing with reading, like you want to somehow make this work. Like, I don't know if you like the arrows. I don't know if you like writing out the words. Somehow you're going to have to convey to yourself what is new, what is old when working through these problems. So yeah, so it's 14%, we'll say.
Well, I put in 60, 70 in parentheses and divided by 60, and I got negative 0.16 repeated. So I
Oh, okay. Sorry. So that you did, okay. Because there's two numbers. It depends on, it's 70 minus 60 over 60, which is 0.166 repeating, or 16.7%.
oh, okay. Yeah.
It's the new minus the old over the old.
Yeah. So I did do something wrong. My fault.
Yeah.
What a doof.
Oh, don't be so hard on yourself. Lots more problems we can look at. Okay, let's look at some more problems here. We're going to switch to exponent rules. We haven't done that yet.
Okay.
These are good problems. You should be able to get a better score on these. It's really like a couple of problems in one. So which expression is equivalent to 12 x cubed over 8x squared? It's really this. It's really 12 over 8 x cubed over x squared. Now, do you remember how to reduce exponents?
I'll remember when you show me, but
Okay.
not
Okay, so the rule is if the bases are the same, so if you have x to the n over x to the m, you subtract the exponents when you're dividing. So
oh,
division turns into subtraction.
okay.
So it becomes x to the power of 3 minus 2, which is x to the 1,
Which would just be X.
just x. And then 12 divided by 8, what number goes into both of those?
4 does. 3
Okay,
over 2.
3 over 2, and the x goes back in the numerator, something like that. So let's have you try one here. Go ahead and reduce that for me, please.
Okay. I got 5x to the third over 2.
Yes, that works out great. Okay, now another property is when the bases are the same and you're multiplying, same bases and multiplying, you add the exponents.
I remember that. Yeah.
Okay, but they're never going to give you one that's that easy. So let's look at, let's say I give you x to the 1/3, x to the 3/4. I want you to simplify that, please.
I don't know how to do that, to be honest.
Okay, so you're adding the exponents, right?
Yeah.
1/3 plus 3/4. To add fractions, you have to make a common denominator. What's the common denominator between 3 and 4?
12.
Okay, so what did you multiply 3 by to get to 12?
I multiplied by 3. So that'd be 9.
Nope,
Oh,
nope. You multiplied 4 by 3, but what did you multiply the 3 by?
4.
So you multiply the top and the bottom by the same number.
So it'd be 13 over 12.
Yeah, be 13 over 12. And that's your final answer. Okay, so you got that down now, right? So your final answer should be x to the 13 over 12.
Yep.
Okay. Now, what if it was x to the a over 2 times x to the a over 3?
I'd pretty much just do the same thing, wouldn't I?
Yes. So go ahead and do that for me, please.
I got 5a over 6.
Yes. Okay, great. Now there's yet another exponent rule that you need to remember. So if you have x to the n to the power of m, you multiply the exponents together.
So it'd basically just distribute the m into the n.
Exactly, yes.
All right.
Now let's say you have x to the 2/3 to the sorry, let me 8/3 power. So you would multiply the exponents. Now, when you multiply fractions, You just multiply the top and the bottom. And sometimes it reduces, but not in this problem.
Okay.
So you ready to try one on your own?
Yeah.
We will get back to some prep questions, but we've got to do this first. So let's go x to the 5/4 to the 3/2 power.
Over. So 15/8.
Yes,
Like,
x to the 15/8. Okay, let's look at finally we can do a problem here. So it says which expression is equivalent to y to the 1/8 power times y to the 3/4 power to the 3/2 power. So this 3/2 is really supposed to be just a tiny bit higher. I don't know why the typesetting isn't right, but it's really, I would write it this way. It's really to the 3/2 power.
okay.
Okay. Now there isn't always an order of operations, but you do want to do the exponent rule first.
Okay. So I just do 9/8.
Yes. Y to the 9/8 and y to the 1/8. Bases are the same. What do you do to the exponents?
Add
Add. So give me that final answer.
10/8. So that'd be 5/4.
Okay. Now I'm gonna show you the answer space, but I don't want you to answer because we do need to learn one more. We do need to learn one more thing to do this. So the answer is y to the 5/4 power.
What the
Okay.
heck?
And you're like, well, which one is it of these? So believe it or not, you already know the answer to this. The square root of x is x to what is the exponent here? What is the same as that symbol there?
I
1/2. 1/2.
1/2.
Okay. Now there's actually a 1 here and a 2 here, but it's not written. So if you can remember this, the 2 is on the outside, the 1 is on the inside.
X equals
Okay, that will help you. So use that mapping to figure out where the 5 goes and where the 4 goes.
So would it be A?
Yes. Here's another problem like that to look
And it's
at.
a different way to put a fraction as your exponent.
Yeah, they're just trying to be difficult. Like your answer, this is correct, but this is a standardized test. It's not about you getting the correct answer. It's about choosing the one that's correct. Okay, this one's really similar.
Which of the following is equal to A 2/3 for all values? So D.
Yes. D. Good. I'm just looking ahead here to see what else we
You're up.
got. Okay, let's do one more and then we'll take a 1 or 2 minute break. What do you think here? What number goes on the outside?
4,
Okay. And then it's 9 to the power of
3.
3 on the inside. And you're like, that's none of them. It kind of looks like B, but it's not. So what is 9 times 9 times 9?
Am I allowed to use my calculator?
Yes. Yeah, go ahead. Probably you wouldn't on this problem, but for us, just use it.
729.
Okay. Now, what's encoded in this, and you're supposed to remember this, is that 9 is really 3 squared.
Oh,
Okay.
cool.
So you're actually supposed to go back to the original and write 3 squared to the 3/4 power. Now, what do you do when you have an exponent to an exponent?
You multiply.
Multiply. So what would that be when you multiply?
Would I just multiply top and bottom?
2 over 1 times 3 over 4.
So it'd be 6/4.
What does that reduce to?
It reduces to 3/2.
So it's 3 to the 3 over 2 power. Now, which is the correct answer?
I'm not gonna lie, I can't see it.
Did you at least write the square root of 3 to the power of 3 from this?
Oh yeah, but
But none of them are there. Do you agree with that?
yeah,
So what is 3 to the power of 3 though?
9.
27. And how do you reduce a root? Build a factor tree.
Oh, so okay, so it'd be D.
Yes. You can do a problem like this, can't you? You you can't give up. You can't say, "Oh, I just guess." Like you've got to be able to work through it. So while you're thinking about that, let's have you try this one. 16 to the 3/4 power. I want you to reduce that without a calculator. I'm gonna step away for 30 seconds, but I'll be right back.
All right.
How are you doing on this one?
So I got 4 square root 16 to the second power, and then I started breaking down to 16.
This is a cube. Um,
Oh,
now, does 16 reduce to another base to an exponent?
2 times 8.
So I'm referring to like 4 squared or 2 to the 4th.
4 squared.
It's actually both. So let's work it out both ways. Let's say it's 4 squared to the 3/4 power. Now what would you do?
Well, I do the multiplication. So I do 2/1 times 3/4,
Good.
and 6/4, which would be 3/2.
So it's 4 to the 3/2 power, which is the square root of 4 cubed. What is 4 cubed?
20, no. 60, is
4.
this
It's 64. What is the
64?
square? What is the square root of 64?
8.
Good. Now let's go the other direction. Let's say it's really 2 to the power of 4 to the 3/4 power. Now what do you do to simplify this?
4/1 times 3/4. So I'd get 12/4, which would be 3/2 again.
No. Try again. 4 over 1 times 3 over 4. It's definitely 12 over 4. But what does that reduce to?
Oh, it reduces down to 3.
Yes. So this becomes 2 to the power of 3, which is
2 times 2 is 4 times
times
8.
2 is 8. Yep. They're supposed to be the same. Okay, so there's a couple of exponent properties here that you really got to know. X to the n times x to the m, you add the exponents. The other one that's really related is when you're dividing, you subtract the exponents.
Okay. Only if
The other-
they're just
Only if there's the same base. If they're an exponent to an exponent, you multiply. What is anything to the power of 0?
one.
1. And then the one that we just did is if you have x to the n over m, this equals the mth root of x to the n, like that. I prefer remembering it this way. But you have to know all of these to be able to do well on this.
Okay.
All right, why don't you take a 1-minute break and we'll start back at the 40 mark.
All right.
Okay, you ready to do a good 10 minutes here?
Yep.
All right. So new question, it is related to all the other ones that we've done. X plus 2 divided by the quantity x plus 2 squared. Which of the following expressions is equivalent to the given expression where x does not equal to -2? Go ahead and give this a try. And if you get the right answer, we'll maybe do one like it. If you don't get it, I'll give you a kind of a reduced problem here to look at.
Okay. Okay.
So let's say this was a over a squared. What would you do to reduce that?
Uh, try to get rid of the squared. I have no idea.
Are the bases the same?
Yeah.
So if the bases are the same, what do you do to the exponents?
Oh, you subtract.
Yes. So what's uncomfortable here is that the base isn't an x, it's an x plus 2, but it's really x plus 2 to the power of 1.
So the exponent would turn into -1.
You subtract and you get, yeah, you get x plus 2 to the -1 power. Now this is a new property. We haven't looked at this one yet. Maybe you already know the answer. So this becomes 1 over x plus 2.
Oh. Because anything to the negative power turns into a 1.
So here's the property. X to the negative n equals 1 over x to the n. But more generally, it's whatever is inside parentheses goes down to the bottom. So let's say it's x minus 1 to the -2 power. This becomes 1 over x minus 1 squared.
Okay, so it just switches so it could change the exponent to a positive number.
Yes.
Oh.
So the other thing that you could do that you might see is what if the exponent, it's 1 over x to the negative n? Well, this
Yeah.
becomes x to the n.
Okay.
So like if it's 1 over x plus 3 to the -4 power, this is x plus 3 to the 4 power. Do you see that?
Yeah.
So if it's negative on top, it goes to the bottom, positive. If it's negative on the bottom, it goes to the positive on top.
Alright.
So let's look at a few questions here. We'll look at them first with numbers. What is 4 to the -3 times 8 squared?
It'd be 1/4
Okay,
and just times 64.
okay. Can you reduce this further?
Yeah, you could turn
Yes.
you could
4 to the third.
put 4 to the third in.
Yeah, what is 4 to the third?
64, so it'd be 1
Yes.
multiply across each other.
Let's try another one here. Let's say it's 9 to the-1 times 3 to the 4th.
So that it'd be 1/9 times that. I'm probably wrong, but is it 81?
It is 81.
And then over 1, so it'd be bring the 9 over to the denominator of 81, it'd be 9.
Good. Okay, so you got that down. Let's say it's 1/3 to the-2 times 2 to the-1.
So I'd bring that -2 to the numerator, and it'd be 9 over
Okay,
1,
9
or
over
just,
1. Yep, that's fine.
and then I bring that 2 to the denominator, and I just multiply from there. So it'd be 9/2.
Okay, good. So let me have you try one here on your own. Oops, sorry. Sorry, -6. Sorry, that'll
You're
work
good.
better.
It'd be 16/64, but I'd reduce 2/8, which would be 1/4.
Yes, 1/4. Okay, so very good. Let's go back and look at this list here. Can you tell me in words what this one is on the left here that I'm circling? What does that say in words? Like, could you, if you're describing it to someone else, what would you say?
I can't see what you're circling.
Okay, really? This over here on the left, can you see it now?
I can see what you're circling.
Okay, all right. So yeah, sometimes it didn't, the cursor doesn't work. How would you describe that to someone?
The bottom left.
Yes.
Okay, so if the if the base number is the same, you could just clearly just subtract the things and get rid of the numerator or denominator, because there's no point of having that.
Okay, so if the bases are the same, you subtract the exponents. Okay,
Yep.
that's crystal clear, right?
And
Okay,
then,
look, we're gonna look at this problem here. It's really two problems in one. Are the bases the same? Are x and x the same?
yes,
So what do you do to the exponents?
subtract them.
So it's -2 -1/3. What about the y's? What do you do with those?
Subtract, so it'd be 1/2 minus 1.
Minus a -1.
So it'd just be +1.
Yes. So I need you to reduce the exponents on both of these, please.
So it'd be -2/3, and it'd be
You're not multiplying. You gotta find a common denominator.
okay. So 3 is -6. -6/3.
-1/3.
Yes, -1/3. So I'm writing this down.
Okay. So yeah, it didn't take a moment or two.
Would it be 3/2 for y?
Y is definitely 3/2. What's the x one though?
-5/3.
But it's -6/3. minus 1/3. So that's minus 7/3.
Oh.
Okay, now when you have a negative exponent, what do you do?
Oh,
Ledger,
you bring it down to the bottoms.
bring it down to the bottom. So it's y to the 3/2 on the top over x to the 7/3. So go ahead and try writing the y as a root.
I put uh the 2 on the square root thing,
Okay.
y to the third.
Good. Okay, over cube root x to the 7th. So from what you have here, we can absolutely get rid of the c. Fortunately, we can't get rid of any of the other ones quite yet. So we have to go like a little bit deeper into this topic, which it's good because that gives us something to do next time. Let me do this real quick over here. So let's say you have x squared square rooted. We'll come back to that problem. This is the same as x squared to the power of 1/2. What is 1/2 times 2?
It's 2 or 1, I mean.
1. So notice how the x comes out. This becomes x. But let's say it's the square root of x cubed. Well, this is x cubed to the 1/2 power. Okay, but it's really inside here, it's really x squared times x all to the 1/2 power. And this is a new property that we'll get into next time. You have to give that exponent to both. It becomes x times x to the 1/2, and it's x square root of x.
Oh, okay.
Okay, so this is actually a good place for us to stop. I'm previewing that for next time, and we'll jump right into more exponent stuff. It's a good unit for us to get strong on. But that is it. I will
Thank you.
see you on Thursday. You're welcome. Hope you have a great couple of days. Okay, bye now.